Yeah, number 20.
If you swap 12 and 13,
Mm-hmm.
wouldn't that mean that 13 is also inverted? So wouldn't that be like 253 minus 2, 1 for 12 and 1 for 13?
No, actually the change only occurs in one inversion. Yeah, so here, yeah, let me explain this. Yeah, because when you talk about inversion, it's about one pair. Inversion, you need to consider one pair, not one element. Yeah, what you said, it looks like you associate inversion with element. Yeah, you said, yeah, because we touch x12, we also touch x13, so that may change two inversions, but actually we only change one inversion here. Yeah, we only change one inversion here. Yeah, because all right, so here, what do we change? All right, if I write here, all right, x12, x13, before we do the swap, we have this pair. The pair is like this. After the swap, we get this pair. Okay, yeah, this pair. So that's the only change we made in this array. And this change tells us, yeah, before the swap, yeah, here, swap. Before swap, there is one inversion here, okay, one inversion. After swap, zero inversion, okay. So that's why the difference is 1, not 2. The difference is 1, not 2. Okay, yeah. Then, if we look at the impact for other places, because the change we made only for a local portion, yeah. Then, if you consider x12 with other elements, then the order has no change, right? If you consider x12 with all the other elements, the order has no change. If you consider x13 with, other elements, the relationship with other elements, then no change. The order information has no change. Yeah. The only change occurs between these two elements. Yeah. And in these two elements, the inversion change from 1 to 0. It's not 2. It's not 2. Yeah. Because the definition of inversion is on a pair. Two elements involved in the definition of one inversion. So when you swap, you only change 1, not 2. Yeah. Two elements involved, but the change for the inversion, only the counting of the inversion, the difference is 1. Yeah. Not 2. Yeah. Although you move 2 elements, okay? You move 2 elements, yeah. But you change 1 inversion. That's the, yeah. All right, let me give you an extreme example. If you want to see my argument, correctly, all right. Now, let us consider 2 elements. How about that? x1, x2. The extreme case, to x1, x2, okay? All right. If in ascending order, no inversion, right? If x1, x2, if they are in ascending order, then 0 inversion. All right. Now I swap x1, x2 to get a descending order. You get 1 inversion, right? Yeah, you get a 1 inversion. The difference is 1, right? Not 2. Yeah. From this simple extremal case, you can see the change of one swap on the number of inversions easily. How about that? Only x1, x2. 0 and 1. Not 2. You never have 2. Because in these two elements, the maximum number of inversion is 1, right? You have no chance to have 2 inversions. Because this 1 already the maximum number if, in a 2-element array. You have no chance to have 2 inversions. Yeah. Only 0 or 1, these 2 cases. Yeah. So if you use this simple example, you can understand, what we do here. Yeah. The change is 1, not 2. Okay. Yeah. All right. Yeah. So that's our discussion here. Yeah. Now let me move to next few. We have last 5 questions. Yeah. Because I want to complete it. Before the end of the class. So for relatively easier question, I want to go a little faster. Yeah. All right. Number 21. Yeah. This one, the biggest problem for this one is the square sharing problem. That's the biggest problem. Okay. Most students couldn't get it. Okay. Yeah. So here, let me focus on the screen sharing part. Yeah. Yeah. Square sharing technique. Yeah, you can call it technique. Yeah, whatever. Yeah. All right. First, we apply the Horner's rule to count the number of multiplications within each pair of parentheses. Okay. Yeah. It's the Horner's rule. Horner's rule on this pair, yeah, the highest degree 3, so 3 multiplications. Okay, yeah, 3 multiplications. All right, yeah, yeah. That's by Horner's rule, yeah, because many students still ask me, how do you get 3? Yeah, we use some special factorization. Yeah, the formula in that Horner's rule, we get a 3. Yeah, so I do not repeat that part. All right. By Horner's rule, in the second pair of parentheses, 1 multiplication, not 2. Okay, 1. Yeah. Then another Horner's rule application, 2 multiplication. All right. Yeah, 2 multiplication. All right. So 1, 2, 3. So we use 2 plus 1 plus 3. So this round we have 6 multiplication. Okay, all right. Then next round, square sharing. Yeah. But square sharing, in order to show you the specific square sharing way, yeah. The first parenthesis I want to use U. Yeah. Second parenthesis I want to use V. And the third one I want to use W. Okay, yeah. So we find the UVW. After these 6 multiplications, we have these UVW values. Yeah. All right. So our P of X equals U to the 8th, V to the V squared, and the W to the 4th. Yeah. All right. Then the first round square sharing, can we take square out inside U to the 4th, V, and W squared, then whole thing square. That's the first round square sharing. All right. Then inside parenthesis, this V has no square. Other than V, other symbols, they have square. So let us, take this v out, all right? Yeah. Then, remaining part, another round square sharing, u square w square, okay? Then square. How about that? Yeah. So here, we try our best to do the square sharing. Yeah. Then we can do counting. Now we're ready. Second round counting. Okay, all right. One multiplication, this u square second multiplication, this dot third, and this square fourth, and the last square fifth. Right? Yeah. Yeah. So the answer is 6 plus 5 equals 11 multiplications. Yeah. That's the way we do the square sharing. Yeah. And many students give me 14. Yeah. The reason they didn't do square sharing, okay? Yeah, because they calculate. You calculate u to the 8th, you have 3, right? There, v squared, you have 1. W squared 4th, you have 2. Yeah, you're adding together, you have 6. Yeah. Then, in this way, it should be 12, right? Oh, because you need 2 more, sorry. Yeah, there is a dot. Yeah, because you need a multiplication. Okay, all right. And, plus 2 more. So here you have 8. Okay, 8 plus that's 6, 14. The reason you use more because you didn't do any square sharing. Yeah. So here, every time you do one square sharing, you reduce multiplication by 1. Yeah. But here we do 3 times. 1 square sharing, 2 square sharing, yeah, sometimes 2, sometimes it depends on how many terms you cover. Yeah, this big square sharing we reduce by 2. This small square sharing we reduce by 1. So 2 plus 1, we reduce 3 multiplications. Yeah, so that's why your answer has 4 more than the best answer, 11. Oh, 3 more. Yeah. Because that big one, you save 2 multiplication, not just 1. Yeah. So try to understand this well, because your midterm question, you will have a similar question. You need to do the square sharing following the solution the way we do here. All right, so that's number 21. Next one, 22. This one, many students did partial correct. Yeah, partial correct, not complete correct. Yeah. So those students, they know it should be a of x plus b of x to the 4th. Yeah, so many students got this step. So that's halfway. Yeah. All right. But you need to calculate. Yeah. The x, a of x plus b of x, you need to calculate. And you need to combine the terms. A of x plus b of x. But some students, they calculate a of x, b of x separately. Then you use more multiplications. If you calculate them separately, although some students reuse the x squared, yeah, then you can save 1 multiplication. Yeah, but still not enough. Yeah, some students use that square repeatedly, yeah, save 1 multiplication, but still not enough. Yeah, Here, we should write it. We combine the terms. Before we do the multiplication, we need to combine the terms. Right? Combine the terms. After we combine because the addition we do not count, right? Yeah. Addition, very fast. Multiplication, very slow. So we don't need to worry about additions. Yeah. So we ignore additions. Yeah. So when you count multiplication, here apply Horner's rule. Okay? Yeah. Horner's rule. Then the degree number of multiplication, so that's 2 multiplications, not 3, 2. Okay, 2 multiplications. All right, so that's inside parenthesis. Outside parenthesis, 4/4, then that's 2. Yeah, because we do another round repeated squaring, 2 multiplication. So the total, 2 plus 2, 4. Total, 2 plus 2 equals 4 multiplication. 2 multiplications. Yeah. And some students give me 10 something. So, some numbers too large. Yeah. The best answer here, 2 multiplication. 4 multiplication. Oh, yeah, many students give me 6. 6 multiplication. I look at their counting, the counting, some places, not quite right. Yeah. So you check your steps closely. Yeah. Some steps correct, but some steps not correct. Yeah. So your counting number, more than the best number. Yeah. All right, that's number 22. Yeah. This one, so many students miss this one. Yeah. The first thing is, several students, they give me the answer greater than this number. That's incorrect. That is, far away from the answer. Yeah. The first thing is, if your answer is greater than this number, then you cannot get any point. Why? Yeah, let me explain. Yeah. Yeah. In order to get some points, yeah, the first thing, you need to move toward the right direction. Yeah, because this greater, it's the wrong direction. Okay, you go in the wrong direction. The first thing is you need to go along the right direction. Right direction should be less than this number. Okay, yeah. So the right direction should be less. Why I say right direction should be less than this number? Yeah. Here, let's consider the finding the minimum. Yeah, finding minimum, but this question we need to change to, because we consider top part. So finding the maximum. Yeah, all right. So this question very close to our finding the maximum problem, and we know the answer, right? Yeah, finding the maximum, the problem, the answer, the best solution is n minus 1. Yeah. And here it is 531. Yeah. So n minus 1 here equals 530. Okay, all right. So the first answer you can consider after you use 530 comparisons, you can get a maximum, right? So the question is the max among the top 6? maximum top 1, right? Top 1 must be in top 6, right? Yeah. So the max, you can use max as your solution, right? You know, not the best solution, not the best solution, okay? Yeah. You know, here, let me call initial solution, okay? Because it's not the best solution. Initial solution. Your initial solution, you can use 530 comparisons that is less than this n number. Yeah, that's the right direction. So your answer should be smaller than this n number, because you have a answer using this many comparisons. All right. Yeah. But you do more than necessary. The work you do here, when you find the maximum, you do more than necessary work. You should not do this much work. Okay? That means your answer should be greater, less than this number. Yeah. Even fewer. The number of comparisons you use should be fewer than this number. Yeah. Okay? All right. Yeah. So here, yeah, we do it this way because top 6, you have some room to manipulate. Yeah. All right. Yeah. All right. So let's do this. Yeah. If one element beats, so here, I draw a diagram. Yeah. All the elements, if we count from 1 to 530, 531, yeah, yeah, the last 6, yeah, last 6, yeah, 29, 28, 27, 26. Okay, all right. Now we want to find, position-wise in top 6. Position, the final position. Yeah. Sorting position. Yeah. Yeah. If we look at the sorting position, top 6. Yeah. All right. Now, top 6, that means that element. Yeah. We need some element. Yeah. That element should be greater than 525 elements, right? Elements. Yeah. So not the, value of this many elements. So that one, okay, if I call x0, okay, that some element should be greater than at least this many, the values of this many elements, right? Yeah. Yeah. From the diagram, we can understand that way. Okay, all right. The question: how do we get such elements? Yeah. Here we use some, smart way. Here we use smart way. Okay, all right. We select arbitrary (526) elements and find the largest one in the set, okay? In this set, okay? Yeah, that set, okay? All right. Because after you find the largest one in this set, that largest one, yeah, because that is the local max, right? Not global, local max. That local max number is greater than there of 525 elements, right? Okay, so that one, because when you find the largest here, you need 525 comparisons, right? And this local max, that is a solution. Yeah. Because you may have many different solutions, a solution. Yeah. So your answer, this is your answer. 525. That is your answer. Yeah. So the number, actually it is this n number minus 6. Yeah. If you need a top 6, so you use n number minus that 6. Top 20, you use n number minus 20, and so on. That's the way we solve this problem. Okay? Yeah. 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 Understand in this way. Okay? Yeah. All right. Then, let's move to the next question. We have 2 more to go. Yeah. So, I think we can make it before. Yeah. I want to complete it 5 minutes before 8. Yeah. Because after that, I need to upload my PDF file for the midterm part B. Then, at 8 o'clock, when the assignment available, you can see the PDF file. Yeah. I haven't uploaded. Yeah. If I upload it, you can see it immediately. So that's why I delay it. Delay it close to 8 o'clock, then I upload it. Yeah. All right. Number 24. Yeah. The answer is 2. Yeah. Many students give me, much more than 2. Non-multiplication, comparison. 2 comparison. Many students give me 4. Yeah. 4 is a common number. Yeah. Several students give me 4, and some students even give me more than 4. Yeah. Several students give me more than 4. Yeah. So why 2? In my hint, I think those students didn't watch my hint video. Yeah. In my hint, I give you some partial information. Yeah. So I told you if we choose 3 of the elements, okay, yeah, because why 3? Yeah, the one in the middle, because there is one above it, okay, so the one in the middle, not the max, right? The one in the middle, not the minimum, right? Yeah. So if you select arbitrary 3 elements, then you'll find the median. This one is the median. Then that could be a solution, right? That is a solution. Yeah. Not the maximum, not the minimum. Yeah. But find the median. So here this way, median of 3. Median of 3. You need 3 comparisons. Median of 3, you need 3 comparisons. That means you have a solution with 3 comparisons. Better than your 4 and the numbers greater than 4. Yeah? So many students give. Yeah. So here the worst answer is 3. Yeah? And when you have this 3 comparison solution, you didn't use this condition. X is not the maximum. You haven't used this condition. X7 not equal to max. Yeah. That means if you use this max, you can only do better than 3. Because you have more information, right? The more useful information. First, we need to evaluate if this information is useful or not. If it is useful, then we can use it to reduce the number multiplication. Okay, reduce from 3 to 2. Reduce it to 2 multiplication. If it's useful. If it's useless, then we get 3 comparisons. But if it's useful, then we can do better than 3. That logic. Okay? So that means when you solve it, you need to target to this 2 number. That's your target, 2 number. All right, so let's do it. Now, in my hand, your first comparison, compare x1 and x2. So don't touch x7. In your first comparison, don't touch x7. Why? Because x7 related not equal to max. Okay, there is some partial known information. This is partial known. You have partial known information. Yeah. If you touch that partial known element, then you may, mess up. Okay, so you don't touch it. Don't mess with that x7 element because it's partial known. Okay, yeah. So you should work on 2 unknown, completely unknown elements. Then you cannot get wrong, right? Yeah, because both unknown. Yeah. So you won't mess anything. Okay, yeah. Right? Yeah. So that kind of thing. Yeah. Now we can assume, x1 less than x2. Okay? Yeah. x1 less than x2. All right. That's our comparison. Then second comparison. We need to find solution. Okay? Second comparison. All right. Yeah. So let me do it quickly. Okay. When we do second comparison, we already have x2 is greater than x1. Okay? All right. We also have the information x7 is less than max, right? Although this max unknown, this max is unknown, but we know x7 must be below max, right? Yeah. All right. Then our second comparison, we want to apply between x1 and x7. Yeah, between x1 and x7. Yeah. Then there are only 2 cases, right? Yeah. One case, x1 greater than x7. Another case, x1 less than x7. Only these 2 cases. Okay? All right. All right. Case 1, if x1 less than x7. So let's try this. x1 less than x7. x7 here and the max. Then this solution, right? Yeah. Because this element, not a max, not a minimum. Between 2 elements. So it's a solution. All right. Case 2, x7. Oh, sorry. Yeah. x1 greater than x7. Yeah. Case 2, x1 greater than x7. Yeah. Let's use this part of the diagram. x2 here, x1 here, x7 here, right? Yeah. Then this is a solution. Because it is between x2 and x7, in the middle of x2 and x7. So In both cases, you only need 2 comparisons. You can find a solution. Okay? Yeah? Yeah. So that idea. So you get the best answer. Okay? Yeah. 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 Think about it. Yeah. The best way. Compare your way with this best way. Yeah. Yeah, because so before we get the best way, we already have a, some way that tells us we cannot do worse than this. We should not do worse than this 3 comparison solution. Okay, that's our starting point. Our starting point is already 3 comparison solution. We can only do better than that. We cannot do worse than that. Okay? Yeah. Yeah. All right. The last question. Yeah. So let me use 5 minutes to complete it. The last question. All right. Yeah. So, yeah. This one. Yeah. So there is a solution. Not very hard. Yeah. Yeah. Not too hard. Yeah. Okay. All right. Yeah. So we are given these 3 inequalities. If we use the diagram, all right, x2, x1, x4, x3, 6, x5. All right? Yeah. So the first round, we want to work on these 2, the first 2 pairs. Okay. The first 2 pairs. Yeah. We want to get these 4 elements sorted. Sort these 4 elements. Okay? All right. So let's compare the top 2 and the bottom 2. Okay. Top 2 and the bottom 2. So 2 comparisons. Comparison 1, comparison 2. Okay, all right. Top 2, bottom 2. Yeah. Then we have the cases. Yeah. Because one is higher than the other, right? Yeah. Yeah. We can assume x2 higher, x4 lower. Okay, all right. Then these 2, there are 2 cases. One case x3 here, one case x1 here. Yeah, x1 less than x3. So already sorted. Okay, after these 2 comparisons, x sorted. Or another case not sorted. Yeah. Still x2, x4. Yeah. All right. Yeah. But so here. Let me use this way. Okay, all right. We know x2 is higher than x4. Sorry, x2 is higher than x4. All right. x4 is higher than x3. Yeah. But x1 is higher than x3. Okay, yeah. We know x2 is higher than x1. Yeah. But between x1 and x4, we don't know which one is higher. We don't know. Yeah. All right. That means we need the third comparison between x1 and x4. After this comparison, we can get it sorted. Okay? Yeah, we can get it sorted. So in this case, we need a 2 comparison get it sorted. So in this case, we need a 3 comparison get it sorted. So this is the worst case. This one is the worst case. Okay? So the worst case, 2, let's say 4, 1, 3. Okay? Yeah. But it tells us after 3 comparisons, we get the first 4 elements sorted. That's the first step. All right. Then second step. Now, this time we have 2 ordered arrays. 2, 4, 1, three two-ordered arrays, another shorter ordered array. All right, yeah. Then you can see one comparison between top two elements in two-ordered array. Yeah, so this is our number 4 comparison, right? Number 4, you get the largest. Okay, all right. Then one comparison at the lower end, yeah. Second, smallest. This is smallest. All right. Then another because in your first comparison you have a loser, right? Yeah. The loser you compare it with the next element in the other ordered array. Yeah. So that means after another comparison, number 6, you get the second largest. Just one more comparison. Okay. Here similarly, either this one or, yeah, right? Yeah. But, worst case, you need a seventh comparison, you get the second smallest. Okay? So the answer is 7. The final, so 7 comparisons. Okay? Yeah. This way. Yeah. Yeah. 2 rounds. The first one just get first of 4 elements sorted. After that, you have 2 ordered array. Then you work on the 2 ends, top end, lower end. Okay? Yeah. Yeah. Top end, 1 comparison, you get a 1 destination element. Another comparison, another destination element. Bottom, you have similar things. Yeah. Okay, all right. Yeah. Okay, so that's all the questions, and I will post the complete solution. So you use this video and my solution file, and because my midterm questions similar to these questions. Yeah. But I change something, but the basic idea, methods similar to these questions. If you have a good understanding, yeah, so then you can do well. Yeah. All right, so that's my timer. Yeah. All right, so I should stop. Okay, so I stop right here, so then I can upload my PDF file of part B. Yeah. So then at 8 o'clock, you can see these 2 assignments. Yeah. Yeah. All right. So any question?
I have a question.
Yeah. Yes.
How is X2, X4, X1, X3 order? How is that in order?
Yeah. So in corresponding the worst case here. Yeah. This is our worst case. Yeah. Worst case, when we do comparison, can we assume X2 greater than X4 without loss of generality, right? Yeah, because they're symmetric. These 2 pairs, from the look, they're symmetric. Okay, one is bigger than the other, so here we assume X2 is greater than X4. Yeah. But then when we do this second comparison, if X1 less than X3, then it's not a worst case because we already get it sorted. Okay? Yeah. So our worst case, X1 should be greater than X3. Okay? Yeah, like this. But for the worst case, we don't know what is the order between X1 and X4. That's why we need a third comparison. Yeah. The third comparison, there are 2 possibilities. Yeah. So your question, third comparison, there is possibility this, right? Yeah. Yeah. It's okay. But this case, yeah, we only have these 2 cases. 2, X4, X1, and X3. We only have these 2 cases. Yeah. But in our next round, which one you use, not that important, right? Yeah. Which one you use. Here, I just select one of the 2. Yeah, just an ordered array. 4-element ordered array. Yeah, yeah. The specific order in this 4-ordered array is not that important. That's why I just take one of the two. Yeah. If I take this version, also fine. Yeah. Yeah. The idea is the same. Yeah. Yeah. So that's the, that's the reason. Yeah. You can select one of the two cases, yeah, to convey the idea. Yeah. Yeah. But because we don't want to write our solution twice, for these two cases, we don't want to write, similar steps twice. Just once, only once. Okay? Yeah. All right. Yeah, so that's all we have to